It's the advent of Cyber 2023, and we are on a mission to save Christmas. McGreedy, you are going down. I have the THM Army with me. Let's go. Yeah. I'm a Papa Shell, but not what you think. Who am I root? Make it dead like sink. We are on a mission, we're here to save Christmas. McGreedy's going down, forget about the riches. Rumors gone around, like Skitty's got snitches. It's an insider threat, and everyone's suspicious. Recon McRed is hunting down a witness. He says he needs our help, so power on your system. Get your black hoodie, boot up the attack box. Hackers come together and take command of the SOC. It's the THM Army. McGreedy will get caught from the 0x1 all the way up to the gods. And we are live. What is up, everyone? Welcome back to my live stream. My name is Tyler Ramsbey, and we are on a mission to save Christmas. I have live streamed now many days in a row. Even before Advent of Cyber started, I was streaming almost daily, but here we are. We are at day 9 of TryHackMe's Advent of Cyber challenge as we are on this mission to save Christmas and take McGreedy down. Without any further ado, let me go ahead and share my screen and we will dive into today's task. Let me just check out chat and make sure I'm not missing anything. Want to say hello to Jaso, aka Justin. Say hello to Chris. Say hello to Default Sec. Looking over at LinkedIn. Always have to refresh LinkedIn. No chat there, but I know there is a few people on LinkedIn as well. So hello to everyone, whether you are watching on LinkedIn or Twitch or YouTube, or maybe watching the video after the fact. Truly, it's an honor for you to take the time and hang out with me. Over on YouTube, Chris said, how often do I stream? I stream pretty often. My set schedule is Wednesday nights, but throughout the month of December, I am streaming every single evening at this time, 8 p.m. Central Standard Time, as we work on this mission to save Christmas. Today, we are doing some malware analysis. As usual, guys, I have not looked at the task, have not even read through it, haven't looked at the walkthrough, so I'm going into it blind. I may totally stumble my way through this. Maybe we'll learn something together. I do know it's malware analysis, and I do know my friend Matt Kiley is the one who did the official walkthrough. So I do want to go back and watch that when I'm done. I had the honor of interviewing Matt Kiley on YouTube a while back, and just like John Hammond, really genuine human being. Really awesome person, and also did his malware analysis course through TCM Security. So I know a little bit about malware analysis, but honestly not a whole lot. So we will dive in and we'll see how it goes. Having retrieved the deleted version of the malware that allows Tracy McGreedy, there's his name again, to control elves remotely, Forensic McBlue and his team have started investigating to stop the mind control incident. They are now planning to take revenge by analyzing the C2's backend infrastructure based on the malware source code. So what are our learning objectives? Well, in this task, we will focus on the following vital learnings to assist Forensic McBlue in analyzing the retrieved malware sample. Number 1, the foundations of analyzing malware samples safely. 2, the fundamentals of .NET binaries. 3, the DNSpy tool for decompiling malware samples written in .NET. And finally, building an essential methodology for analyzing malware source code. So malware handling 101. Let me just highlight this. Handling a malware sample is dangerous. Always take precautions during your analysis. And I will just say, guys, if you want to get into this through TCM Security, Matt Kiley's course on malware analysis is incredible. He actually has you set up an entire VM architecture. So you have like a host machine, then you actually have a Linux machine that functions almost like the internet that's running, and that your host machine thinks is the internet. So when you detonate malware, you can see network indicators of compromise, host-based indicators of compromise. He does a really good job of walking you through how to set up a malware lab safely. So if this is something you want to dig into, check out that course through TCM Security by Matt Kiley. I also think Matt has posted much of the course on his YouTube page, so make sure you check that out if you have not already. As mentioned, handling malware is dangerous because it is software explicitly designed to harm, steal information, or compromise the security and functionality of computer systems. Given this, we will again introduce the concept of malware sandboxing. So what is sandboxing? Well, a sandbox is like a pretend computer setup that acts like a real one. It's a safe place for experts to test malware and see how it behaves without any danger. Having a sandbox environment is essential when conducting malware analysis because it stops experts from running malware on their actual work computers, which could be risky and harmful. A typical environment set up in malware sandbox contains the following: network controls. Sandboxes often have network controls to limit and monitor the network traffic the malware generates. This also prevents the propagation of malware and any other assets. Virtualization. Many sandboxes use technologies like VMware, VirtualBox, or Hyper-V to run the malware in a controlled, isolated environment. This allows for easy snapshots, resets, and disposal after the analysis. And finally, monitoring and logging. Sandboxes record detailed logs of the malware's activities, including system interactions, network traffic, file modification. These logs are invaluable for analyzing and understanding the malware's behavior. Looking back at the chat, want to say hello to Krishna and Roger over on LinkedIn. Awesome to have you guys here. And on Twitch, Justin said Twitch is ahead of YouTube. Yeah, Twitch seems to have the least amount of buffer. So if you want to be the closest to real time, join Twitch. But all the platforms are fine. Want to say hello to Z. He watched Husky Hacks. Yeah, Husky Hacks or Matt Kiley. He's awesome. Agent Pseudo Room. That's a good room as well. Awesome. All right, let's keep going. So I already launched the VM and split screen view, so we're good there. If you want to RDP in, there are the creds. Optional, building from the VM on day 8, you can use that password to unlock the zip archive. What? There was... Oh, it means like, I see. It means like day 8 was yesterday when we used FK Analyzer, or whatever the heck that thing's called, FTK or whatever that's called. That's what it's referring to. Anyways, however, for our convenience, the VM on this task will have the defanged. Fangs are gone. Place in the artifacts folder on the desktop. Check the intro to malware analysis room as a refresher. Let's see, have I done this room? I haven't. What? I should though. I'll make sure I do that on stream sometime, guys. Introduction to .NET compiled binaries. .NET binaries are compiled files containing code written in languages compatible with the .NET framework, such as C#, VB.NET, F#, or Managed C++. These binaries are executable files with the .exe extension or dynamic link libraries. They can also be assemblies that contain multiple types and resources. Hey, just going to give a commercial to myself, guys. I made a YouTube video recently that's kind of blown up on how to create a fully undetected reverse shell with NIM to make it a .exe binary on a Windows system. As of now, it fully bypasses Windows Defender, and you can spawn a reverse shell with it. So if you want to know how to use NIM to do some kind of malware, more like reverse shell obfuscation type stuff, check out that video on my YouTube page. I think you will enjoy it. I'll show you how to bypass Windows Defender in like 5 minutes. All right, compared to other programming languages like C or C++, languages that use .NET, such as C#, don't directly translate the code into machine code after compilation. Instead, they use an intermediate language, like a pseudocode, and translate into native machine code during runtime via a common language runtime environment. This may be a bit overwhelming. So in simple terms, it's only possible to analyze a C or C++ compiled binary by reading its assembled instructions at the low level. Meanwhile, C# binary can be decompiled and its source code retrieved, since the intermediate language contains metadata that can be reconverted to its source code form. All right, so some basic C# programming. Based on the ELB's initial checks, it has been discovered that the retrieved malware is written in C#. So let's quickly discuss C#'s code syntax to analyze the sample effectively. Note, we can skip this if we're already familiar. I'm kind of familiar with C#, but for each one of these rooms, I want to do the entire thing, especially for those who might be new. I don't want to skip any of it. So let's keep going. All right. Namespaces, classes, functions, and variables. For this section, let's use this code snippet. So we have our namespace demo only. We have some classes being started here. So let's read through it ourselves first. So we have the namespace demo only. Then it looks like we're setting a class, this basic programming class. And then we have essentially a function here. And then what's our function doing? Well, all this doing is string to print. We can kind of guess what this is. Hello world, and then show output. So the first function here is going to print hello world. I don't know if function is the right language that we're doing, but I'm thinking of Python, which I think it is. Yeah, functions and variables. Public static void show output string text prints the contents of the text variable. Simply, this is a print function. Console write line text. So details. Let's go through this. Namespace. So that's right there. A container that organizes related code elements such as classes into a logical grouping. It helps prevent naming conflicts and provides structure to the code. In this example, the namespace demo only is a namespace that contains a basic programming class. So class. We have our class right there. defines the structure and behavior through functions or methods of the objects it contains. In this example, basic programming is a class that includes the main function and the show output function. Moreover, the main function is the program's entry point where the program starts its execution. And now we have our functions. So this is the main where it's starting. Our function is the show output type stuff here. A reusable block of code that performs a specific task or action. In this example, the show output function takes a string through the text argument as an input and uses it on console.writeLine to print as its output. Note that the show output function only receives one argument based on how it's written. And finally, a variable. A name storage location that can hold data such as numbers, integers, text, strings, or objects. In this example, toPrint is a variable that handles the text hello world. And that's right there. So we're saying string toPrint. So we're setting our variable here and we're calling it the type string. So we have to, unlike in like Python, we don't have to specify the type. We have to specify the type. So if it's a number, we specify integer, but we have string. And then we have our variable name toPrint and we're storing hello world in that. And then we're printing that. For loops. A for loop is a control structure used to repeatedly execute a block of code a specified number of times. It typically consists of three main components: initialization, a condition, and iteration. Let's use the example below, all right? So if we look at this, before we even look at how they explain it, we have the for loop, of course, and we have integer, so think number. For integer, I equals 1, so we're setting our initial counter right there. So our integer, I equals 1, and then as long as I is less than or equal to 5, add 1 to it. So it's going to print I love McSkitty 5 times. In this example, the loop is initialized with 1. So if you, hopefully you can picture that. We start with, maybe I can pull up a notepad. I don't know if we have notepad on here. Oh, we do, okay, cool. Right, so if we start with I equals 1, that's how it starts. And all it's saying with this I line right here is as long as I is less than 5, do something. And what do we want it to do? Well, I++ is really just shorthand for I plus 1. So it's saying, hey, as long as I is less than 5, then keep adding to it. But once it equals 5, then stop. And what are we going to do each time? Well, we're going to print I love, maybe back up, I love McSkitty. So it's going to do that until the I equals 5. So it'll print I love McSkitty, add 1 to it. I then equals 2, I love McSkitty, I equals 3, I love McSkitty, I equals 4, I love McSkitty, I equals 5, I love McSkitty, and it's going to stop because it's going to be 6, and it only wants to print if its I is less than or equal to 5. So once it hits 6, our for loop is going to stop. So in this example, I already explained that enough. Loops can be immediately terminated using the code break. Conditional statements. Conditional statements like if and else are control flow statements used for conditional code execution. They allow us to control which code block should be executed based on a specified condition. So we can walk through this together. We have if the number is greater than, right? I always remembered in school, like the alligator eats the bigger one, right? So if the number is greater than 5, then do what? Well, console print line, the number is greater than 5, else the number is less than or equal to 5. Makes sense. Importing modules. C# uses the using directive to include the namespaces and access classes and functions from external libraries, so kind of like import in Python. So using system. After importing, we can now use all the classes and functions available from the system namespace. Got it. The code snippet above loads an external namespace called system. This means that this code can now use everything inside the system namespace. All right, don't worry if you find this code snippets a little overwhelming. Once we start analyzing the malware, the following sections will be much easier to understand. All right, looking over the chat, Hashu on Twitch said, following you step by step. Awesome. Hopefully you're finding something helpful. Bufford said, I remember as alligator also. Yeah, did the alligator eats the bigger number, right? Z said it's part of the SOC pathway. Oh, the malware analysis thing. THM? I use THM. Oh, yeah. Yeah, TryHackMe. You're right. All right, let me make sure I'm not missing anything on LinkedIn. I am not. Okay. Let's keep going. A C2 primer. Well, according to Forensic McBlue, the retrieved malware sample is presumed to be related to the organization's remote mind controller C2 incident. So to build the right mindset in solving this case, let's look at the run through below about malware with C2 capabilities. A C2, or command and control, refers to a centralized system or infrastructure that malicious actors use to remotely manage and control compromised devices or systems. It serves as a channel through which attackers issue commands to compromise entities, enable them to carry out various activities such as data theft, surveillance, or further malware propagation. So let's walk this through. User executes the malware. So my NIM reverse shell that I wrote that bypasses Defender, that could be the initial entry point. And when they execute that, it connects to the C2 server and asks for instructions. And you can do a lot of things, like even Metasploit itself is a C2 server. You can take screenshots of the user's screen. You can implement a keylogger, all that good stuff. Well, not good if you're the victim. The C2 server responds with a set of instructions. So we go back to here. The malware executes the instruction. So, hey, take a screenshot. That might be the instruction. Malware reports back the output, and the C2 server connects to our attacker to be executed on the victim machine. So our attacker is the one in control. And there's often a beacon that beacons back to the C2 server saying, hey, yes, I'm here. I'm still connected, all that good stuff. Seeing C2 traffic means that malware has already been executed inside the victim machine, as detailed in the diagram above. In terms of cyber kill chain stages, the attacker has successfully crafted and delivered the malware to the target and potentially moves laterally inside the network to achieve its objectives. To expound further, malware C2 capabilities typically exhibits the following behaviors. One is HTTP requests. C2 servers often communicate with compromised assets using HTTP requests. These requests can be used to send commands or receive data. 2. Command execution. This behavior is the most common, allowing attackers to execute OS commands inside the machine. And 3. Sleep or delay. To evade detection and maintain stealth, threat actors typically instruct the running malware to enter a sleep or delay for a specific period. During this time, the malware won't do anything. It will only connect back to the C2 server once the timer completes. And often, it'll even check like, hey, am I in a sandbox, doing things like a sandbox? If it's in a sandbox, it won't even execute. Decompiling malware samples with DNSpy. Now that we've tackled the theoretical concepts to build our technical skills, let's start playing with fire. Since we already assumed that the malware sample is written in C#, we will use DNSpy to decompile the binary and view its source code. DNSpy is an open source .NET assembly C# debugger and editor. It is typically used for reverse engineering .NET applications and analyzing the code, and is primarily designed for examining and modifying .NET assemblies in a user-friendly, interactive way. It's also capable of modifying the retrieved source code, editing, setting breakpoints, and running through the code one step at a time, aka debugging. I need a drink of water. Note, as mentioned above, we won't execute the malware, so the debugging functionality will not be discussed, so we're just doing static analysis then. To proceed, let's go to the virtual machine and start the DNSpy tool by clicking the shortcut on the desktop. Andrew said I skipped all the reading and just answered everything, basically just code reading. That's fine, we learn stuff either way. Z said, off topic, but Tyler, I did a comparison of OffSec Pen 200 versus THM. They have all the same modules. Watch your video on Pen 200. Yo, Pen 200 sucks. I passed the OSCP my first attempt in 8 hours using TCM Security and Hack the Box and TryHackMe. Those 3 resources were so much better than OffSec's official stuff, and I pwned the OSCP. So be like me and use the better resources. What up, Galactic Garlic? First, I like your name, my friend. Good to have you here on Twitch. All right. Once the tool is open, we'll load the malware sample. So if you're following along, we're going to go. Can I make this bigger, actually? Oh, I can make that part bigger. I can't make the buttons bigger, but hopefully you guys can see it okay. So the downside though, default set, is you still have to pay for the labs, dude. So I paid like the 90 days because that was the least I could do. So $1,500, and didn't do the extra credit. I just like YOLO'd it. I didn't have the extra credit, didn't go through the lab material, did my own study plan with TryHackMe, Hack the Box, and TryHackMe, and boom, pwned them. All right, file, open. It was on the desktop, wasn't it? Oh, okay. I'm getting too ahead of myself. When you get the prompt, click the following to navigate to the malware's location. Now that you are inside the malware, that switches over to all files. because it's defanged, so the .exe executable is removed. Blah, blah. Next, double-click the malware sample loaded into the application. There we go. Once the malware sample is loaded, you'll have a view like the image below. The next step is to click the main string, which will be take to the entry point of the application. All right, we have our namespace and everything there. As discussed in the previous section, the main function in a class is the program's entry point. This means that once the application is executed, the lines of code inside that function will be run one step at a time until the end of the code block. However, we won't be dealing with this function yet, since reviewing it without understanding the other functions embedded in the malware sample can be a bit confusing. That it can be. Understanding the malware functions. You might have been a little overwhelmed when you saw the main function. All right, we can look at this ourselves a little bit, and I can actually understand what's going on a little bit even as I look at this. Looks like a pretty simple code here. Anyways, let's keep reading the text though. Focusing on the individual functions before dealing with the main function can be considered a modular approach. Doing this allows us to easily break down the malware's functionalities without getting bogged down with long code snippets. Moreover, it allows us to recognize the potential execution patterns that ease our overall understanding of the malware. To start with, view the list of functions inside the program class by clicking the highlighted section as shown in the imager below. So here's what we're doing. All right, here's our different ones. We have a decryptor, an encryptor, execute command, a get it, implant, main, post it, sleeper. So we can kind of guess what those are in real malware. It's not going to be nearly as clear. After clicking, you will see the functions in the drop-down menu. Let's run through them individually to better understand each code's meaning. You can click on the items as we discuss them to compare the code in DNSpy. It's also advisable to read the .NET Framework documentation to learn more about it. So let's do this ourselves first, and then we'll look at what it says. We'll see if we can do it ourselves. So get it. So we have our juicy Tomatoy program thingy. Crypto miner or toy miner, I don't remember what it was in the last task, but we're setting a string, get it, from a URL, so static, it doesn't change, and so we're making a web request, creating a URL, we're setting our user agent, getting the response. So this must just be like remember we talk about how C2s communicate over HTTP and HTTPS. This is kind of the communicating back and forth, I believe, like getting the instructions. Let's see if I'm right. Based on the source code, the getIt function uses the web request class from the system.net namespace and is initialized by the function's URL argument. The name is already a giveaway that the web request is being used to initiate a web request to a remote URL. You can render the namespace details by hovering over the web request string, similar to what you see in the image above. So that's just what it's talking about. By default, the HTTP method set to the web request class is get. This means we can assume that the HTTP request made by this function is a get request. The 3 lines of code inside the function can be expanded by the comments written for every line. So, accepts one argument, which is the URL, right there. Initialize the HTTP web request class with the target URL from the argument function, and then return the response. Got it. In other words, the getIt function accepts a URL as its argument, configures the parameters needed for the HTTP GET request custom user agent, and returns the value of the response. All right, post it. Okay, so another similar thing, we have our URL and data. So we're not just sending the URL in this argument, we're also sending the data back from what I can see. We have our same HTTP web request with a URL, and then we're encoding it with ASCII. So we're encoding our data, our bytes with ASCII. We're making a post request to a form. That's just basic HTTP stuff. User agent, content length. This is like the actual HTTP request that we see going on here. We're writing it to a request stream. So we're just posting the data back. So we have a get and a post request essentially. Like the getIt function, the postIt function also uses the web request class. However, you might observe that it has configured more properties in the first one. The most notable is the method property, wherein the value is set to post. This means that HTTP request made by this function is a post request, and it submits the second argument as its post data. The notable lines are annotated with comments on the code snippet below. So it accepts two arguments, so we noted that URL and the data to be sent, converts the data argument into bytes, and then sets the HTTP method and prepares the data to be sent, and then returns the response. In simple terms, the postIt function accepts an additional argument as post data, which is then submitted to the target URL and returns the response received. We have our sleeper. Okay, so we're literally just sleeping it by whatever count is passed to it. So that's our sleeper, to kind of hide. The sleeper function only contains a single line, a call to the thread.sleep function. The thread.sleep function accepts an integer as its argument and makes a program pause for milliseconds based on the value passed to it. The usage of thread sleep is typical behavior malware uses a pause its execution to evade detection and execute command. Okay, so execute command. It receives a string, which is a command. So like who am I, ID, get UID, things like that. And we're starting an actual OS process. So this must be from the system namespace, I'd assume. And you can see all we're doing is we're doing a command.exe/c and then our command. So very basic Windows stuff going on there. Okay. Given the namespace and the class name, it seems this function is being used to spawn a process. According to Microsoft documentation, from the initialization of the process start info properties, we can also see that the file to be executed is command.exe and that the execute command's argument is being passed as a process argument. In short, the code snippet results in that. Another thing to know is that the Windows style property is set to process Windows style.hidden. This means that the process will run without a window. As such, it's a way to hide the malware's malicious command execution. This function serves as the malware's OS command or execution function. Encryptor. No, we'll be diving deep into cryptography. Let's look at it though. All right, drink of water before we look at this. We have our encryptor, which accepts plain text. You can't hack this super secure C2 keys. So we're encoding it with, is that the key that we're encoding it with? Oh, we're AES 256 encoding it with that key. So I think it's just AES encoding it with this key, I think, if I'm understanding that correctly. The giveaway in this function are the AES classes used in the middle of the code block. If you hover on the initialization of the AES managed, yeah, it also shows the namespace system security cryptography. You guys see that? Which somehow means that everything here is related to cryptography or encryption. Moreover, the encryptor function accepts an argument and encrypts it using the hard-coded key right there and the IV values right there. And lastly, it encodes the encrypted bytes into base 64 using that. Did I miss that part? Oh yeah, I did right there. In summary, the function encrypts a plain text string using an AES cipher together with the key and IV values and returns the encoded base 64 value of the encrypted version of the string. And there's a TryHackMe machine where you actually hack a C2 server. Gosh, I don't remember what it's called, but like the C2 server is making a request out without giving too much away, and you have to hack it, and you can actually see some of this in play. Wonder if I can find that. It's not intro to CT. It's an actual like CTF machine that I thought was really unique. If anyone knows what it is, let me know. I did it while I was at DEF CON. That's when it came out. Implant. The last function is the implant function. So what's this one do? Well, it accepts a URL, and then we convert from base 64 string. So we're converting from base 64 string from the getIt program. right there. So that's going to send as base64. We're decoding that. And we have this git folder path. Oh, spykit. Oh, are we installing this? Are we installing the spykit? It looks like that's the malicious.exe we're installing, I think. On the last function, it accepts the URL string as argument, initiates an HTTP request to the URL argument, and decodes it with base64. It also retrieves the app data path and attempts to write the contents of the base64 decoded data into a file. Lastly, if the implanted file was written successfully, it returns its location. If not, it returns an empty string. Retrieves the location. Writes the downloaded data. All right. In the context of malware functions. How long is this room, guys? Oh, that's a flag. Okay, we'll come back to it. In the context of malware functions, the implant function is a dropper function. This means it downloads and stores other malware inside the compromised machine. Building the malware execution pipeline. Now that we have analyzed the other functions in the malware sample, we'll return to the main function. Again, viewing the main function source code is a bit overwhelming since its code block contains over 60 lines. To make things simple, let's try to split the analysis into 3. Let's see if we can go through it ourselves real quick. So we have this static, well, this is just the main function. We're setting a host name, DNS get host name, and our string is McGrady secret c2.thm, and then we're doing our string /reg, so it must be that /reg, like register, I suppose. Name /host name, so that's kind of our victim's host name. We're registering the victim's host name. We're doing that posted function, so sending that URL in the data. Initializing account of 15,000. Is that for the sleep function possibly? Now here's our sleeper. So string program.getIt, decryptor. So all stuff that we kind of see is just putting a lot of it together now. We have our implant right here. So our implant's being stored on stash.mcgradythm spykit.exe. So that's where the implant is coming from. And then we have our encryptor, of course, encrypting stuff. All right, I mean, seems to make sense. And we even have like arguments being passed. Like this would be the attacker on the C2 server saying, hey, what do you want to do? Sleep, shell, implant, quit. And then you're sending that command to the victims, I believe. The first code section before the for loop does the following. Retrieves the victim's machine's hostname. Yep, just like I said. And then number 2, we initialize the HPO URL together with the data be submitted to the reg endpoint, which is registering it based on the host name. 3 is execute the HTTP post request to the target URL. Yep. Got it. Initialization of other variables, which will be used in the following code lines. And I think this is like the one being used for sleep. As you can see, most of the lines in this section are all about initialing values in a variable. However, there are 2 notable function calls being made. The call to DNS hostname, which is at the top here, right there, function that retrieves a victim machine's hostname. The attempt to distinguish the compromised machines based on their hostnames is typical malware behavior. We've already discussed the post-it function, and we know that it makes a post request to the URL, the first argument, right there, and submits the host name as its post data, the second argument. In this initial step, it seems that the malware reports the host name of the compromised machine first to establish the C2 connection before executing the other functionalities. The code inside the for loop before the code block if statement. Right there. And that's where it's like for, it's based on the commands that we are executing. In this section, you'll see that the for loop is written without any initialized values on the initialization, condition, and increment statements. This means the loop will run indefinitely until a break statement is used because, like, it'll just keep asking, hey, sleep or shell, implant or quit, blah, blah. Quit must be the break. Afterwards, the first line inside the loop block uses the sleeper function wherein the count variable is being passed. Remember, this variable is already initialized before the for loop statement. The following code lines are variable initializations wherein the string 1 and string 2 there's string 3, where's string 1? Oh, well, I'll find it. Oh, is it up here? String 1 and string 2. If the value of the string is evil and the value of string 2 is test, the resulting value for variable will be evil task test. Got it. Eventually, the URL2 variable is used by the getIt function to do a GET request to the past URL, and the result is stored in the it variable. Lastly, the execution flow will enter the if statement only if the it variable is not empty. You may view the detailed annotations in the code snippet below. Yeah, it's a C2. You're right. What up, Paddock Sec? Happy hacking, y'all. Nice to meet you. I must go back to studying. Peace out, Galactic Garlic. Oh, you thought Avon and Cyber has hacked the box? No, it's THM, my friend. Justin over on YouTube, so I definitely appreciate your walkthroughs. I look forward to these live streams each channel. Hey, thank you. And Z said, as do I. I like staying online for these. Feel like a small group event. Yeah, that's probably the benefit of me not, being super well known. Like some of those bigger streamers, they have like legit moderators just to moderate the chat and bring questions up. I don't have enough chat to do that. I just have different windows pulled up so I can look at all the chat when I want to. So this for loop syntax signifies a continuous loop since it has no values. So that's key. Continuous loop is what that looks like. The sleeper function is being used. Got that. Initialization of other variables, GET requests. Okay, that all makes sense to me. In summary, this section is focused on the preparation of variables to execute the HTTP GET request to the task endpoint and enters the if statement code block once the condition is satisfied. Code executed within the first if statement. Is that this one right here? Yeah, so that's where it's asking the attacker, hey, what do you want to do, I think. Continuing the execution flow, the code block will only be reached if the GET request in the task endpoint contains a value. The section before this, if does not A equal sleep, if A does not equal sleep, is that what it's saying? Is focused on initializing the variables A and text. It starts by decrypting the string stored in the it variable and splits it with a space character. The A variable's value is the first element of the resulting array, and the text variable combines all elements in the same array, excluding the first element. The example below shows how the it variable is being processed. So step 1, split the decryptor string with a space. Array equals decryptor, it, split. Store the first element into the A variable. A equals array, so A equals shell. Combine the remaining elements excluding the first using space. If array length is greater than 1, then text combined with space, netlook group administrators. All right. To simplify, the code snippet discussed above focuses on setting up the values of the A and text variables which will be used in the succeeding conditional statements. Wow, this is a long room. Okay, we're almost to the end of the explanations. Nested conditional statements. The next session focuses on the conditional statements based on the A variable's value. This is like the arguments. You might see that the conditions in the if statement are all set to not. If not, that's what I was saying before. This means that the condition is satisfied is equal to sleep, and we'll go inside the code block to assess it with another condition. Check if A variable is not equal to shell. Otherwise, it will jump to its counterpart. Else, we can simplify this code to pseudocode like this. If A equals sleep, then execute sleep. If it equals shell, execute shell, implant, quit, quit. You can follow the if-else pair by clicking the if in the if statement line. Oh, I see what it means. So if I click like this, oh, I thought it was working. So there's that one. So if it's implant, then we're going to download the implant. I see. I got you. And then the contents of each conditional statement can be summarized in the table below. Sleep sets the value of the count variable, which is being used by the sleeper function. Shell uses the execute command function to run OS commands, encrypts the command, and reports the encrypted string to the C2 server. Implant executes the implant function with the redacted domain, encrypts the output of the implant function via the encryptor, reports the encrypted string to the C2 server, and then quit sets the flag variable to true. Remember that the A variable's value is based on the response received after making an HTTP request to the task endpoint. This means every condition in this code block is based on the instructions pulled from that endpoint. Hence, it can be said that the task URL is the endpoint used by the malware to pull C2 commands issued by the attacker. Moreover, all the implant and shell command responses are submitted as post requests to the URL3 variable. Remember, this variable handles the results endpoint. All command execution and implant outputs are reported to C2 using the results endpoint. This may be a bit overwhelming, so let's summarize the key learnings regarding this code block. The A variable, which is dependent on the GET request made to tasks, contains the actual instruction pulled from the C2 server. This seems to be the command and control functionality, wherein the malware's succeeding actions depend on the commands the attacker sets within the C2 server. 2. The shell and implant command responses are submitted as post requests to the results endpoint. This seems to be the malware's reporting functionality, wherein it sends the results of its actions back to the C2 server. And finally, the instructions pulled from the C2 server are limited to the following: sleep, shell, implant, and quit. And finally, breaking the loop. Lastly, the final condition statement at the end checks if the flag variable is set to true. If that statement is satisfied, it will execute a break statement. Got it. This means that the if statement that contains a quit condition makes the indefinite for loop stop, terminating the malware execution flow. Congratulations, you have completed the malware sample analysis and to discover some notable C2 endpoints that can be used to take revenge on McGreedy. Okay, let me look over at chat. I just finished TCM security and AD. What should I do next? Become a pen tester. TryHackMe has some really good AD rooms that I would encourage you to check out our AD networks. Z said, I admit I did not read all this. I looked at the code. Yeah, you miss stuff when you don't read all of it, I think. So like when I go through TryHackMe rooms like this, I really do make it a point, guys, of reading everything in its entirety, even if I'm familiar with it. Because when I don't do that, I notice I get stuck on silly things because I failed to read it. And hey, reading's good for you guys. I enjoy reading books. Long reading does not bother me at all. So I'm totally fine with the long reading. It's a good life skill. Default Sex said the same thing. The long read fried me before going to the questions. Okay, so yeah, PatSec, actually, if you do the malware analysis course through TCM Security, you actually do analyze real malware. It's like part of the capstone, like WannaCry and stuff like that. So if you haven't done the TCM Security course on this, you set up your own VM and everything and do malware analysis safely with real malware. It's really fun. Okay, what HTTP user agent was used by the malware for its connection request to the C2 server? Well, if we go back to this one right here, I believe this is the answer it's looking for. What is the HTTP method used to submit the command execution output? Well, we know that's a post because we can see that here. What key is used by the malware to encrypt or decrypt the C2 data? So if we go over to our encryptor, we saw this here, the key and the hard-coded key and IV values. What is the first HTTP URL used by the malware? If we go to the main one, it's that guy right there. Whoops. And then reg to register the malware. How many seconds is a hard-coded value used by the sleep function? Okay, whoops. What did I just do? I did not mean to do that. So here we don't have it. It's taking it from count. So if we look at main, we have to see where is count. Count is right there. So 1500 milliseconds is how many seconds? I don't know. Oh, duh. Why did I have to Google that? Obviously it's 15. Silly Tyler. What is the C2 command the attacker uses to execute the commands via that? That's just shell, I think. What is a domain used by the malware to download another binary? And we actually saw that right here. That is the stash.mcgreedy.thm. And finally, check out the malware analysis course in the SOC Level 2 path if you enjoyed analyzing malware, which I will do. I'm actually working through the SOC Level 2 path myself. I'll show you guys how far I am in it. I've done all of log analysis, I've done all of advanced Splunk, and I'm working through advanced ELK right now, and I've done a few of these other ones, I think based on the security engineering path. And I've done some of the malware analysis, but not much of it. So when I go through that, guys, I'll try to live stream it and we can work through it together. Boom. But we have completed the room. So hey everyone, thank you again for taking the time to hang out with me. I have like a lot more people than I usually do, especially on Twitch. So thank you guys for being here, for helping me through it. Hopefully you learned something in the process as well. Roger said, I won't complain anymore after seeing you read the whole room. Dude, I do this and all of this. So actually, if you watch my AD videos, I work through every AD network on TryHackMe. I read everything in its entirety. We miss stuff, guys. Truly, you will miss stuff if you don't take the time to slow down and read and seek to fully understand the material. And when you don't understand it, go back and ask questions. Like, ask questions as you're going through it. Look stuff up when it's confusing. That is the best way for you to learn. So, hey, guys, thank you again for taking the time to be here, for learning alongside of me. Just a reminder, I am doing this every single night through the Advent of Cyber series. So I'll come back again tomorrow night, same time, same place, around 8 p.m. Central Standard Time, and I will be here. Let me look at the chat before I sign off. Pat Seck said, leave THM and go hack the box for CPTS path. Actually, dude, I have subscriptions to TryHackMe. I have subscriptions to Hack the Box's main platform, and I have subscriptions to Hack the Box Academy, and I'm about 80% done with the CPTS path. So it is good stuff, but I don't think it's either or. I think it's both and. I enjoy both Hack the Box and TryHackMe, and I have subscriptions to both and use them both about the same. Actually, if you watch my live streams, there's really a good mix between TryHackMe and Hack the Box machines that I do. I don't know if I favor one or the other in my streams. I go back and forth pretty often. But guys, thank you for being here. I will catch y'all in the next one. Peace.